So guys, in this video we're gonna give our ranged enemy the ability to look for the player character and track him when he no longer sees him. So we're gonna start by going to the ranged enemy folder, and we're gonna create what we call an environment query. So we're gonna add the EQS querying system to our behavior tree. EQS querying system is a system that makes part of the AI framework in Unreal Engine. This allows the AI to draw a map of locations or actors inside the level and to evaluate them and test them based on different criteria to allow the AI to make a decision in a given context in the gameplay. So I'm gonna start by right-clicking in the ranged enemy folder. In artificial intelligence, gonna select environment query. So this environment query we're gonna name track player. So we're gonna open it, and here we have the root node. We're gonna create a generator. So this is gonna generate a map of points around the ranged enemy character inside the level. So we're gonna choose a grid-shaped map, and what we're gonna do, generate around the querier, that is the ranged enemy character. We're gonna add a test to these generated points. They can be points, they can be locations or actors. So we're gonna add first a trace test. So we're gonna look for the points that have a line of sight to the player character, and we're gonna filter away those who doesn't have a line of sight to the player character. We're gonna only keep the points that have a line of sight to the player character. Of course, in the level we're gonna see all the points when we test the EQS, but the one which are filtered away are gonna be blue colored. We're only interested by those who are not filtered away. So trace to querier on visibility. Context. The context is the frame of reference for this test. It should be the player character. So we're gonna create a new context inside the ranged enemy folder. New blueprint class. In all classes we look for context. Environment query blueprint base. We're gonna select this base class. We're gonna name our context player context. There we have it. In this context we're gonna override one function, which is provide single actor. Now it should return us the player character, so very easy. Get player character and wire to the output, and we save our context and we close it, because we're no longer gonna modify it for this game. We select it in the context menu, player context, for the trace test. Of course, It's gonna be a filter only test. A test in the EQS system can be a filter only, score only, which gives scores to the drawn, which gives scores to the points of the grid around the query. It weights them, or both filter and score test. Filter and score test. So gonna just choose here. Just wait a little bit. I'm adjusting my screen. I'm gonna choose filter only test for the purpose that we want. Trace data, we don't change anything. Trace from context, we're not gonna change it. We want trace test to the context, which is the player character. The frame of reference, we don't change anything inside these two settings. Bool match, here the test, as you can read, require hit, but we are looking for the points that have a line of sight to the player character, which means there is no hit. So we're gonna inverse the test, require not hit, and we keep everything else as it is. We save, and then we add a new test. Now that we have we got the points that have a line of sight, now we're gonna choose the best point. We're gonna score them. We're gonna give the highest score to the point that is the closest to the player character. So we're looking for the point that have a line of sight to the player character, and which is the closest one to him. So we add a new test, a distance test. It's gonna be a score only test. Distance to player context. Here prefer greater, but we prefer lesser for the purpose of what we want. So we're gonna inverse the test. Scoring factor, we set it to, instead of 1, minus 1. Minus 1, prefer lesser. And we leave everything else as it is. Filter, it's not a filter test. That's right. So that should be all for our environment query. Now it's ready to be called from the behavior tree. I'm gonna drag this branch to the left because our behavior tree is gonna be bigger than that for the finished product. Basically, we're gonna have two more main branches with sub branches. So for this one, we're gonna keep the focus task, and we're gonna add a new task, run EQS query. So of course we're gonna go to this branch. We're gonna run this branch when the ranged enemy cannot see the player character. So he's gonna look for him. So here we're gonna add what we call a decorator, which is a condition that allows the execution of this branch. So add decorator blackboard based on a blackboard key. Here we choose can see player as the tested blackboard key, and that's it. We don't modify the notify observer and the observer aborts because at this point they do the job just fine. Later on we're gonna modify them, yes. So key query should be not set, which means the key should have a value of false. He cannot see the player. Back to the run EQS query. Here we choose our newly created environment query, track player. And we're gonna do, of course, this environment query is gonna return us a result, which is the closest line of sight point to the player character. So we're gonna store it in a new key in the blackboard. It should be of vector type, and we're gonna call it target location. That's it. Back to the behavior tree, and we store the result there. Blackboard key, target location. Having set our target location, we're gonna move to it. So we have an already pre-created task. Move to, which make the ranged enemy move to the given location or given actor. So here we're gonna choose as the goal the target location, of course. Then he's gonna focus after having reached the location. He's gonna focus on us, aim at us. So we keep the task focus. That should be all for the modification right now to our behavior tree. Now, having done all of this, it's time to test the EQS query inside the level editor before running the game. So we're gonna use our EQS testing pawn that we created, and of course we're gonna create a new context for testing purposes. So again, environment query context blueprint base, and we create it. We name it test player context. This is for testing inside the level editor. We open it. Before that, we're gonna drag inside the level. Gonna go to content browser 2 for ease of use. We're gonna drag a first person character instance inside the level. It's gonna be our frame of reference for the test. Test player context, we override the same function, single actor, and here we're gonna do get all actor for classes, get all actor of class, get all actors of class. There it is. Actor class first person character, and the out should be alright, get all actor of class. I'm gonna compile. The output we're gonna we should do for each loop before. Of course, it's gonna be a one item only array, because we only have one instance in the level anyway. So we're gonna do a for each loop, which gonna do only one loop. This loop is gonna set the returning resulting actor, and that's it. So it's gonna return us the instance of first person character class inside the level. This is our test context. We close it, and now we should modify the track player environment query, just the context, test player context, the new frame of reference, test player context, and that's it. So we're just here testing before loading the gameplay. Now what we should be doing, we're gonna add the environment querying pawn, the EQS testing pawn, which is very handy for EQS. Gonna put it right there, and we're gonna set his environment query in the details panel. We navigate. That's the track player environment query. Right away you see the grid, you see the map of the points. The grid is small, so we're gonna modify some settings in the generator in the environment query. There, grid half size should be 9000 because it's too small, it doesn't span the entire area, and the space between do not have a hit on the performance because it's gonna be a dense map, as you can see. We're gonna add more space between each point, so between the points, to have a lesser number of points inside the grid. And we are back to the level. This is what we want. We have the map, we have our first person instance. I'm gonna just drag the side of the level viewport to the left a little bit to have more visibility space. So as you can see, we have the points that doesn't have a line of sight to the context, to the first person instance, colored in blue, and we have the rest colored from red to green, with the green color indicating the highest scores and the red colors indicating the lowest scores based on the distance to the first person instance. The winner for this EQS query is this point. It has the highest score, 0.94 score. So this is where the ranged enemy should go when we are here at this point, the location of the first person instance. So we're gonna swap the actors. So I'm gonna put the ranged enemy in there in the place of the EQS testing pawn. Our player start, we're gonna put it in there in the place of the first person instance, and we're gonna remove the first person instance from the level. We're gonna make sure, of course, to go back to the player context as a context for the environment query. So in the trace test, back to it, player context, distance, back to it, and we save, and we're gonna see what happens. Play. Right away he's going to that point that we've seen and he's aiming at me. He's not straight aiming at me because he's using the aim offset, which is good for the purpose of the game, for the elevation aiming, but it doesn't allow him to aim straight at me in the behavior tree. We're gonna just fix this with a simple modification, or simple setting change. So I'm gonna stop the gameplay, go to the ranged enemy, and in the details panel we're gonna set the use controller yaw rotation. This way, when the AI controller focus on the player character, the ranged enemy instance is gonna fully rotate in the direction of the yaw control rotation. Use controller rotation yaw. We just set that part of the controller rotation to affect the ranged enemy pawn, and we save, and that's it. Back to it, we hit play again. Of course we're gonna use the yaw rotation of our aim offset, but it's just fine for the purpose of this game. So if I jump, he's aiming at me in the air, but I'm gonna do AI debugging here by hitting the apostrophe key. I'm gonna go behind this block. Now it's false, so he's moving to another point. and he's aiming at me. That's it. So guys, thank you very much for watching this video, and see you in the next video. Goodbye.